Our experiment was carried out in the free version of Google Colab, and this video is going to give a tour of the notebook and focus on how it was designed for our experiment. We will go through each part, explain its purpose, then show off the results when running each cell. If you would like to access this notebook to look closely into the details, I have put a link to my GitHub in the description of this video. Navigate to the repo titled Stable Marriage Exploration, as we can see here, and click into the Stable Marriage IPYNB, like this. We'll have a button at the top that says Open in Colab. You want to click this button and it will open the notebook on your device. I already have it open, so I will pull it up here. You may follow along with me and potentially try this experiment on your own if you would like to. This notebook has several parts to examine, so let's take a look at each one. First, we have the introduction of our research question, which is what trade-offs emerge between deterministic stability and computational efficiency for the stable marriage problem and its related problems. So first we have the introduction to our algorithms, which gives a description of the procedure for each algorithm in plain English. Then we'll show the algorithm analysis for time complexity, and then has the actual code for each algorithm. The next section contains the functions used to time the algorithm and then print the results for each algorithm. Next, we have a note about datasets for this experiment, which we'll get to when we actually open up each cell and talk further about the experiment. Then we have our functions that generate preference lists because this experiment uses computer-generated artificial data. So these are the functions used to do that process. Then we have running and timing our hand-created data. These are very small inputs that we designed to show that the algorithms are functioning as intended, and it also makes it easy to manually inspect things on smaller data. And then we have running and timing the generated data for user-defined input sizes. And then finally, we have the averages and plots for our run of the experiment, which I'll explain a little bit more later. Then we just have getting the hardware characteristics since we are running on a virtual machine. So this will just give you an idea of how everything is working at time when you run it. And then finally, we have the sources that we used to get all of this information for this experiment. All right, so starting from the top, we have the algorithm's introduction, and I will go into incredible detail on each of these cells, but I wanted to open it, show you what it looks like, and show you the Google Colab notebook running every cell. So we have the Gale-Shapley algorithm. So we have the procedure in plain English. We have the algorithm analysis for its time complexity. And then we have the actual code for the algorithm. And these are commented out so that anyone who is unfamiliar or wants to know exactly how we did this can see very clearly which steps were taken and what the intended purpose of the steps are. And this is the same general format that each of these introductory cells will follow. So we have the Gale-Shapley algorithm, randomized serial dictatorships, RSD, with and without heaps. So I have a little blurb that talks about how the RSD algorithm is not designed to solve the stable marriage problem because it only has one set whose preferences are taken into account. So we acknowledge that this is not going to be used for the stable marriage problem in practice, and we are only using it for experimentation purposes. And then we have the randomized serial dictatorship in plain English, the efficiency analysis, and the code, and then the same thing for the random serial dictatorships with heaps. We tried to implement heaps to see if it would speed up the process if we introduced the data structure. Here is the procedure in plain English, the analysis of the algorithm, and the code used. Then we have Irving's algorithm. which also is not designed to solve the stable marriage problem, but instead solves the stable roommates problem, where it takes one set, which has to be of even cardinality, and the set contains each participant and their preferences of the participants in the set. So we have the procedure in plain English, the time complexity analysis, and the code for the stable roommates problem, aka Irving's algorithm. All right, so that is the algorithm's introduction. Then we have functions that time and print each algorithm. So for the Gale-Shapley, we will time. So we start time, we run the Gale-Shapley algorithm, and then we end it. And then we calculate the time elapsed for the algorithm to run, and we return that time. And this will be the same, you'll see the same structure for every algorithm. It will follow just like this. So I won't open them all, but you can see it for the Gale-Shapley. And then to print, we will get the matching from running the algorithm. Then we will output the matching for each pair and return the output. And again, this will be very similar for every algorithm, so I'm not going to open each cell, but this is the whole purpose of the functions to time and print each algorithm block. A note about datasets for this experiment. So, our input will be the same to test the Gale-Shapley and randomized algorithms, but the input to test Irving's algorithm will require a different type of input. This is important because this created the problem where not all of our algorithms accept the same input, so we had to account for Irving's algorithm throughout the rest of the experiment. So, next we have functions to generate preference lists. So our experiment uses generated artificial data, and we have one run that does hand-created data, which I'll talk about here. But for the generating artificial data, we have random preferences for Gale-Shapley and RSD, and random preferences for Irving's. And then we have worst case preferences for Gale-Shapley and RSD, and worst case preferences for Irving. And this is our block to run in time hand-created data. So I'll show we just create our own dictionaries that we will be using. And this is for Irving's algorithm since it has a different input. All right. And then we have running and timing generated data for user-defined input sizes. This is where the bulk of the experiment happens, so I will spend the most time explaining these cells. So, this gives an explanation for if you are looking at this notebook on your own, but I will skip this since I'm going to be explaining it in this video. So first we have data collection for performance chart. This cell will ask you to input the maximum number of in the input size. So if you put in 100, it will generate inputs up to those sizes. So it will do generate for 10 inputs, and then it will run Gale-Shapley and time it. And then it will generate 20 inputs, run Gale-Shapley and time it on 20 inputs, and it will do this all the way up to 100 for whatever you decide your max input is. So I said 100. It could be anything. And then once you do that, this cell beneath it will plot each point. So if you did 100, it will plot for the random scenario, generating random inputs, how long it took the algorithm to run for each step of the input size, for random and for worst case. This cell beneath them all, this is for more, this is not used for the experiment. This is more just so that you can mess around with timing each algorithm. And so you can get more specific with what you want to test with this cell. And then finally, we have the averages and plots for our run of the experiment. So this only reflects the results from our trials and input sizes, which we conducted November 18th, 2025, around 7:30 p.m. CST. And because this experiment involves inherent randomness and it's running on Google Colab's virtual machine, the outcomes will be different depending on when you run it. So this just collects all of the averages of our data into a data frame that we feed into this cell, which will plot them for the random scenario and the worst case scenario. Finally, we have this cell, which just gets the hardware characteristics for when you are running this experiment. And then, like we saw before, the sources. So with all of that being said, I will run all of these cells so that you can see them in action now that we understand what each of them are doing. So first, I will run the algorithm introduction cells. When I run this, it will actually run the code. And this is what we need this to have been run so that later cells can reference when they call Gale Shapley. If we don't run this beforehand, it won't know what that function is because it hasn't been run, if that makes sense. So I'll go ahead and run this whole part. You'll click run anyway, and we will allow it to run. Okay, now we don't have that little loading circle, so we know this one is run and ready to go. Then we will run the functions to time and print so that we have the functions available to us. All right, that one's done. There's nothing to run here, so I won't run anything. Functions to generate the preference list, we will run this because we are going to be referencing these functions later. And then we can go ahead and run these. I will expand this and I will run this. It's going to generate the results for Gale Shapley and randomized algorithms. So I'll go ahead and run. Okay, it ran in 0 seconds and it will be the same because nothing changed, but you can see that it reproduced the results that we had originally. Okay, and then this is, like I said, this is where the real bulk of the experimentation happens. So let me run these all individually. Here we go. So we'll ask me the maximum number of men and women and participants for Irving's. I'm going to select 10. Okay, and then it will show me running for n equals 1 up to 10. It outputs the maximum, for the maximum n, how long it took for each scenario algorithm, and it is timed in microseconds. And then with this data that we just collected, it will feed into this chart. So I will go ahead and run this, and these charts will change based on what we generated up here. Here we go. As you can see, it's a little bit crazy when you do such small input sizes, but the charts, they will follow a general shape the higher your input gets. And then we can do the one where we test our own specific number that we would like. And I will display this when you choose to print the matches and when you choose not to. So let's say we wanted to do a small number because this one I will display the matches. So I will do, let's do 5. And if you recall, Irving's algorithm needs a set of even cardinality. So for this one, I will choose 6. And I do want to print the matches. So I will select yes. Perfect. So now for our randomly generated data, it shows us the time it takes for the algorithm to run, and it gives us the matching. And we can see for Irving's algorithm, there was no stable matching for the instance generated. And then for worst case, again, same idea, and there was no stable matching for the instance. Then that makes sense because this was the worst case. Now let's try it where we don't print the results, but we should still see the time it takes for the algorithms to run. So let's do 100 for each. And I will say, no, I do not want to print the matches. All right, and we still get the time, but we don't see the matches because that would take up a lot of space. Okay, and then finally, these averages that we will be running, I will still run the cell, but the averages are hand put in there from our experiment. So this won't change at all, but I still want to display how this works since this is a tour of the notebook. So I will run this. It will put all of the data into this table, and this table will be fed into our chart generation cell where we will get these. graphs. Perfect. And then I'll go ahead and run this to get the hardware characteristics upon this demonstration run. There we go. Those are the results of the hardware characteristics, and sources used remains the same. All right, that is all I wanted to display with this notebook. I hope you found it informative, and I encourage you to try it on your own if you are interested.